All right, so now we get into drawing angles in standard position. So remember, we were just talking about radian measure and the unit circle. So remember that one full revolution of a circle is 2 pi radians. So if you go, which is illustrated here, I think I'll skip over here. If you do half a revolution, that would be 1/2 of the 2 pi. That would be pi radians. So notice that corresponds to 180 degrees. And I think that's something we also mentioned earlier. If you do 1/4 of a revolution, that would be 1/4 times 2 pi. That would be pi over 2 radians, corresponds to 90 degrees. And then the one I skipped over, 3/4 of a revolution, 3/4 times 2 pi would be 3 pi over 2 radians, corresponds with 270 degrees. So remember, those are your quadrantal angles. Okay. All right, let's see. A few examples here. They want me to draw and label the angle theta equals negative pi over 4 in standard position. So remember, standard position means the initial side along the positive x-axis. This is a negative angle, which means we're going to rotate clockwise. Okay. And they're just reminding you here that, well, if it was pi over 4, that would be 1/8 of a revolution. So they're saying to go 1/8 of a revolution clockwise. So that looks like this. This is the angle theta equals negative pi over 4. Okay. So got, I think, 2 more examples like that. Go to the next one. Now they want me to do 3 pi over 4. If you're watching the video, why don't you pause the video and try this one. Okay, so let's look at alpha equals 3 pi over 4 radians. This is a positive angle, which means we're going to go counterclockwise. Now, this calculation that you see here is really not that necessary. I think it makes more sense, since we just were thinking about pi over 4, to just say that 3 pi over 4 would be 3 times that, right? So they say 3/8 of a revolution, but as long as somehow you get here, that's really what matters. So we did talk earlier about how pi, oh no we didn't, we talked about pi over 2 being 1/4 of a revolution. Well, in the last example, it kind of came up that pi over 4 is 1/8 of a revolution. Okay. Believe me, by the time you know, we get further into this class, and especially when we get through pre-calc, you're going to know these things in your sleep, whether you want to or not, almost. All right. Okay, and then we have one more example. Beta equals negative 7 pi over 4. Okay, so let's see what that looks like. That is a negative angle, so we're back to going clockwise. So I think the way that makes sense to talk about this is just to take your negative pi over 4, which was exactly example 4, 2 examples ago, and just imagine, what does 7 times that angle look like? Okay, instead of doing that. All right. So let me turn on my spotlight here. Oh, there it is. Okay. So this is where negative pi over 4 was. So if you go 1, 2, 3, 4, 5, 6, 7, you end up here. All right. So basically just doing a 45-degree angle 7 times. All right, one more example of drawing angles in standard position. They want me to draw and label the angle gamma equals 13 pi over 4. So hopefully by now you've got a decent handle on where pi over 4 is. Pi over 4 is 45 degrees. So you would just count, you know, start with a 45-degree angle and then count 13 going counterclockwise, right? So what would that look like? That would look like This would be 1, 2, 3, 4, 5, 6, 7, 8. So you start over when you get to 8. Then it goes 9, 10, 11, 12, and lands down here. This would be 13 pi over 4. So it's going around one whole time and then another 5/8 of a time. All right. Okay. This is a very important chart right here. You're going to see this again and again and again. So we were just talking about the multiples of pi over 4, and you see those sort of in the middle. Let me turn my spotlight back on here. So there's pi over 4. Here's pi over 2, 3 pi over 4, pi. And then it goes 5 pi over 4, 6 pi over 4, also known as 3 pi over 2, and then 7 pi over 4. Okay, those are the multiples of pi over 4. Multiples of pi over 6 are also very important. Imagine that you took a straight angle, 180 degrees or pi radians, and cut it into sixths. So the sixths would look like, this would be the first one right here, pi over 6. The second one would be at 2 pi over 6, aka pi over 3. Then you would get to 3 pi over 6, aka pi over 2. 4 pi over 6, also known as 2 pi over 3, and then 5 pi over 6. And it continues down through quadrants 3 and 4. I'm not going to bore you right now with every single one of them. And then over here, they just have the negative version. So when you go clockwise, remember negative angles are run clockwise. So you would hit them going around in this order. So one of the major things we do in trigonometry in the next section of chapter 4, which is not the next section I'll cover, but in the next section of chapter 4, we're going to define the trigonometric functions. And one of the things that we're trying to make you an expert at in this class and in pre-calculus is being able to evaluate these trigonometric functions at these specific angles. So you're going to see these again and again and again, and like I said earlier, hopefully learn them in your sleep. Okay. All right. Here are some of the angles that we just talked about in the form of a table. So I'm not going to spend too much time going over every single detail of this. One of the very first things we talked about was quarter of a revolution. Quarter of a revolution is pi over 2. That's your 90-degree angle. If you cut that in half, you get an eighth of a revolution, which is pi over 4. That's your 45-degree angle. And then you have your multiples of pi over 6. Okay, pi over 6, 2 pi over 6, aka pi over 3, and then et cetera, et cetera, et cetera. Okay, and I believe that continues on to one more slide. Again, it's not really important to go over every single one of these right now. They're just showing it to you in a couple of different forms. Okay, and that brings us to coterminal angles. If you think about that last example with drawing the angle in standard position, the one that was 13 pi over 8. Actually, let me go back to that real quick. One thing that might have occurred to you, it occurred to me while I was talking about it, is that if you start up here at pi over 4, and then you go 1, 2, 3, 4, 5, 5 pi over 4 would land in exactly the same place as 13 pi over 4 did. Okay, those two angles would have the same terminal side. The only difference is to get to 5 pi over 4, you don't go all the way around. You just start here and stop there. Okay, whereas with 13 pi over 4, you have to go all the way around and then go around 5/8 of a revolution. Okay. So 5 pi over 4 and 13 pi over 4 are an example of what we call coterminal angles. Coterminal angles have the same terminal side when they're drawn in standard position. Okay. So the main thing that we want to do here, because we're going to get really comfortable working with angles that are either between 0 and 2 pi, if they're in radians, or between 0 and 360 degrees, if they're in degrees, okay? So if they give me a really, really big or a really, really negative angle, I want to find a certain angle that's coterminal with that, and that'll be easier to work with, okay? Sorry about my messed up animation there. So increasing or decreasing the degree measure of an angle in standard position by an integer multiple of 360 degrees. What that means is that you're just taking an extra trip or 2 or 3 or 7, all right, around the circle, okay, but you're landing in the same place, all right. Thus, an angle of theta degrees is coterminal with an angle of theta degrees plus any multiple of 360 degrees, all right. That's what this mathematical mumbo jumbo means right here. It means theta degrees plus any multiple of 360 degrees. Okay, you'll land in the same place. Same idea for radians. So if you take a certain angle in standard position and add or subtract a multiple of 2 pi, you're going to get an angle that has the same terminal side. Okay, just didn't go around the same number of times, or maybe did not go around in the same direction. That's all that is. Okay. All right, so here's how you find coterminal angles. Okay, a 400-degree angle. So they want me to find a positive angle less than 360 degrees. So in other words, between 0 and 360. That is coterminal with a 400-degree angle. So a 400-degree angle is not that hard to picture. It just means go around the full 360 degrees and then go another 40 degrees, right? So the way that we do that officially is we just say, okay, I am going to subtract 360 degrees as many times as I need to get the smallest positive angle that I can. And in this case, that's only once. You only have to do it one time. You do 400 degrees minus 360 degrees, and you get 40 degrees. So a 400-degree angle and a 40-degree angle are coterminal. Okay, they have the same terminal side. Next example is a negative 135-degree angle. Okay, try to picture what that looks like. Okay, it means you're going clockwise, 45, 90, 135. I kind of wish I had a circle here. All right. When you have a negative angle, you have to add 360 degrees until you get an angle that's positive. And in this case, that's only one time. If I add 360 degrees one time, I get 225 degrees. All right, in the next example, the angles are in radians. So remember, when you're finding coterminal angles that are measured in radians, you have to add and subtract multiples of 2 pi, all right? And I know it's not comfortable thinking in radians, especially when you're not used to it, but that's okay, we'll get better at it. So assume the following angles are in standard position. We want to find a positive angle less than 2 pi that is coterminal with a 13 pi over 5 angle. Let's talk for a second about why the answer 13 pi over 5 doesn't work. If you think about 2 pi and you get a common denominator, 2 pi is the same thing as 10 pi over 5, isn't it? And that means 13 pi over 5 is bigger than 2 pi. So that does not work. 13 pi over 5 means it went around one full time and then part way around another time. So this is a little bit like my 400 degrees example. And the way that we fixed 400 degrees was we subtracted 360 degrees. So for this one, we're going to subtract 2 pi. Okay? So I have all the details written out here. Let me turn this back on and explain what I did. So I'm saying that if you take 13 pi over 5 and subtract 2 pi, I get a common denominator. That's the same thing as 13 pi over 5 minus 10 pi over 5. 2 pi is exactly the same as 10 pi over 5. And then 13 pi over 5 minus 10 pi over 5 is 3 pi over 5. And that would be my answer. Okay. All right, and then the next example is negative pi over 15. So this is a negative angle. The way that you fix negative angles is by adding multiples of 2 pi. And I think we're only going to have to do that one time. So if we take negative pi over 15 and we add 2 pi one time, I get my common denominator. 2 pi is the same thing as 30 pi over 15. All right, and then negative pi over 15 plus 30 pi over 15 is 29 pi over 15. Okay, and that brings us to the last topic for section 4.1, which is the length of a circular arc. So you may remember that the way we defined radian measure earlier in this section is we said theta equals s divided by r. So s was the length of the arc, which you see right here, and r is the radius of the circle. So what you see here is just that same equation written in a different form. Instead of theta equals s divided by r, I've multiplied both sides by r, and I've come up with s equals r times theta. So where I'm going to use this is when I know the radius of the circle and I know the radian measure of the angle, I can use that to get the length of the arc. So here's an example of that. A circle has a radius of 6 inches. Find the length of the arc intercepted by a central angle of 45 degrees. And they want the answer written in 2 different ways. First, they want an exact answer, which would be written in terms of pi. And then they want me to round my answer to 2 decimal places using the calculator. Okay. So very, very important when you're doing a problem like this, you have to first convert this angle to radians. So you remember how that works from earlier in this section? To convert a degree angle to a radian angle, you multiply by pi divided by 180 degrees, and we talked about how it makes it a little easier to remember if you picture the degree symbol canceling each other, symbols canceling each other out. So there's one on top, one on the bottom. So that gives you 45 pi over 180, which simplifies to pi over 4. So that means r is 6 and theta is pi over 4. You have to write it in radians. So that's going to give me that the length of the arc is 6 times pi over 4, which is 6 pi over 4. Now I just noticed that for the exact answer, this 6 pi over 4 really should be simplified to 3 pi over 2. So let me do that really quick. If I can get my pen out here. Okay. Yeah, we want to simplify that to 3 pi over 2. Okay. And then if I ask the calculator what is the approximate value of 3 pi over 2, it's about 4.71 inches.